Okay, so some of you guys have said that the math review didn't make any sense and that the video that was posted wasn't really helpful. So I'm going to go through a few of these just to show you guys what's going on. So number one says how many kilograms equal 1860 grams. Okay. So I don't want the equal sign there. Sorry. So if we open our parentheses, what's on top goes on bottom, right? So we put grams on bottom and we go straight to kilograms. Now if we look over here, it tells us that a kilometer, which we don't care about the base unit, I only care about the prefix. So kilo means 1,000. So that means there are 1,000 grams in 1 kilogram. So that'll be 1860 divided by 1,000, which is 1.86 kilograms. Okay. This one is a little different, but not too bad. The one that we're about to do will help you do these next two. So we want to know how many millimeters equals 20 kilometers. So we open our parentheses. What's on top goes on bottom. Okay, the only difference here is we can't jump from kilo to milli. We have to go through our base unit. So we need to go from kilometers to meters. Okay. What's on top goes on bottom. Then we can go to millimeters. Okay. So like I said before, 1 kilo is 1,000 base units. Okay, and if you look right here, it says there are 1,000 millimeters in 1 meter. 1,001. Okay, so it'll be 20 times 1,000 times 1,000. Okay, so it'll be 10 times 10 to the 7th millimeters. Which makes sense because a millimeter is super small and a kilometer is significantly larger in comparison. So that's why it takes so many to fill up 20. Good. Just make sure that you're going through that base unit. Don't let these bytes scare you. Okay, this is not a big deal. Okay, so this next one, isolation of variables. All this is doing is making sure that you remember how to do basic algebra. Unfortunately, a lot of us don't remember how to do basic algebra. So I'm going to say this one, this was 2. Now we're going to talk about 5. So AB equals CD. All this is saying is separate each variable. Like, okay, I know how to get that C by itself. I need to divide this side by D, divide the other side by D, which gives us C equals AB over D. Okay? It's just saying to do that for all of them. So if I had it for, if I want to get B by itself, I would divide both sides by A. And I would get B equals CD over A. Okay, this is just checking if you remember how to do everything. If you need to go ahead and pause it to get that, pause it because I'm going to erase it and go on to number 6. So number 6, same thing. I'm just going to give you one example. AB equals C over D. If I want to get C by itself, I need to multiply by D. Okay, so I should get AD over B equals C. Okay. You should know that if it's on bottom, the way to get rid of it is to multiply it, both sides by it. And if it's on top, you need to divide both sides by it. Okay? Because it's showing you that because when it comes down here to the gas laws, you have to manipulate equations. Okay, and that's what we're going to do real quick. We'll go down to some of these. I know it separates the gas laws, like Gay-Lussac's law and Boyle's law specifically, but as long as you can do the combined gas law, that is what I care about, and that's all you're really going to need to know ever. So I'm going to work on mine in a similar fashion. So, all right, I'm going to erase these. Okay, let's talk about this example 1 right here. How many moles of acetylene gas occupy this many liters of STP? STP should ring a bell to you because we did talk about this in class. This is what you need to know for STP. 1 mole equals 22.4 liters. So if I want to know how many moles C2H2 equals 3.25 liters, open our parentheses, what goes on top goes on bottom. We can go straight to moles because we have the conversion. And we know that 1 mole is 22.4 liters. So it should be 3.25 divided by 22.4, which is 0.145 moles C2H2. Sorry, I'm writing really crooked. Good. We'll talk about this molecules one. That was example number 1. This is example number 3. My cat's meowing in the background. Sorry if you can hear it. Okay, so I want to know how many molecules equals 187 liters of that gas at STP. So I want to go liters on top, liters on bottom. We can go straight to moles. Okay, and if you guys remember Avogadro's number, which is our mole to molecule conversion, we know that 1 mole is 6.022 times 10 to the 23rd molecules. Okay. We know that 1 mole is 22.4 liters. Okay. So we have this times this divided by 22.4. Unfortunately, I do not have a real calculator. I have my phone right now, so I can't work this out. I probably can, but I don't know how to work my phone as well as you guys do. So remember that whenever you put this in your calculator, whatever you're using, this goes in parentheses. That is a big deal. Otherwise, you'll get the question wrong. Okay. So 187 times 6.022 times 10 to the 23rd, all that divided by 22.4. That'll give you your answer. Okay. This one is, all of these are conversions, right? So all of these that we've talked about so far are going to be using our parentheses and things like that. Now these little red writings that I have on the corner, now is when I actually need to use them. I haven't needed them yet. Oops. Okay. So let's do example 5 from this section, changing the millimeters of mercury into atmospheres. So millimeters of mercury, torr, ATM, these are all just pressures, right? So usually, like, we sit at a regular 1 ATM, which is 760 torr, or 760 millimeters of mercury. Okay, so we're setting this up the same way that we've done everything so far. I want to know how many ATM equals 745 millimeters of mercury. Open our parentheses. What's on top goes on bottom. We can look right here. 760 to 1 ATM. Okay? Cancel, cancel. You're left with what you need. So you should do 745 divided by 760, which is 0.98 ATM. Okay. If you're doing ATM and you get a really high number, something is wrong. Okay? ATM should be super low because, like I said, our normal is 1. Okay? Okay, we'll do 6. What's the pressure of kPa into atmospheres? So I have kPa here as well. This stands for kilopascals. So how many ATM equals 97.5 kPa? What's on top goes on bottom. So we have 101.3 kPa to 1 ATM. These cancel. You're left with what you want. So we should have 97.5 divided by 101.3, which is 0.96 ATM, which is reasonable. Good? Okay, let's move on. Okay, so earlier I told you that the difference in the laws didn't matter. Because if you do this for every single question and just mark out what you don't need, then you don't have to remember any of that stuff, okay? So when we're talking about gas laws, it's P1V1 over T1 is equal to P2V2 over T2. Sorry, I put an I with that V because sometimes we say P initial, but V1 works. V1, okay? So let's look at example 8. This says, so the first thing we need to do is let's line this out. I know it's tedious, but until you're comfortable with it, this is the best way to work through these problems. Okay, so if a sample gas has a volume of 25 liters, there's our volume, when the pressure is 100 kPa. What is the volume when the pressure falls to 75 kPa? Okay, notice it did not say anything about temperature, so we can cross it out. Okay, we don't care about it, which makes it Boyle's law, right? Because it specifically says pressure volume. Okay, but like I said, if we do this every time, we just mark out what we don't need. So do this. Don't fight me on it, okay? Solve for your variable before you plug in your numbers, okay? So we can get rid of this. So our new equation is P1V1 is equal to P2V2, right? And we need V2, so we need to get it by itself. We divide by P2. So we have V2 equals P1V1 over P2. Now we can plug in our stuff. Okay, I'm going to move this over here. So V2 is equal to 100 kPa times 25 liters divided by 75 kPa. Okay? I'm telling you, solve for the variable first. So we have 100 times 25 divided by 75. So our new volume is 33.3 liters. Okay? Good? Okay. Let's look a little bit further. Okay. I'm going to erase this. I scrolled down to Charles' formula law, but we don't need to know who did what. We just need to know the combined gas law. Okay? So we have P1V1, over T1. Okay? So this is another example 6. Oh. Okay, so we'll write these out. P1. Okay, a sample of air has a volume of 22.5 liters. Sorry, I said 22.5. I meant 2.25. Temperature is 298 K. If the temperature increases to 73 K, I'm having a hard time with numbers today, without changing the pressure. Notice, no pressure change. So we don't care about pressure anymore. Okay? What's the new volume? So our new formula that we need is V1 over T1 is equal to V2 over T2. And we want V2. Okay? So to get it by itself, we multiply both sides by T2. And that'll cancel these out. So we now have V2 is equal to V1 T2 over T1. Now we can plug it in. So we should have V2 equals 2.25 liters times, that was our V1. I said the last thing I remembered was saying V2 and I was confused about it. Okay, now our T2, 373 K, divided by our T1, which is 298 K. Okay, so 2.25 times 373 equals, divided by 298 equals 2.82 liters. Notice that the units, your temperature needs to be in Kelvin, and as far as this goes, volume, sorry, as far as your volume goes, as long as it remains constant, it shouldn't matter. Okay, temperature in Kelvin. Okie doke. Let's do example 9. Okay, should stop erasing these so I don't have to write it every time. Okay, so the pressure inside a car tire is 195 kPa at 300 Kelvin. Okay, at the end of the road trip, the pressure on a hot, sunny day has risen to 225 kPa. What is the temperature inside the air of the tire? Okay, so no volume. Get rid of these. Okay. So our new equation should look like this. P1 over T1 is equal to P2 over T2. We need our T2, so we need to get it by itself. Okay, so times T2 times T2. Sorry, I didn't mean to cross that out. So we should have T2 equal to P2. Now we multiply this by T1. This one is longer, okay, obviously. This cancels out. So now we have T2, P1, P2, T1. These subscripts are very important, okay? Because if you have the wrong P's and T's, then the whole thing's going to be wrong, okay? So make sure you're keeping up with that. Lastly, we divide it by P1. So our final should be, I'm going to write this one in red because I've been writing all over the place. T2 equals P2, T1 over P1. Okay? Now we plug it in. How that would have sucked if we had been dealing with numbers that whole time, okay? That's why I'm specifically telling you to solve for the variable first. T2 equals 225 kPa times 300K divided by 195 kPa. Okay? Let me do it real quick. 225 times 300 divided by 195. 33.8 Kelvin. Okay. That doesn't sound right. Because it's not right. Okay, I put something in my calculator wrong. So the reason I said that didn't sound right is because it specifically says on a hot, sunny day, which means your tire should have gotten hotter, right? And mine was 33.8, which is like almost absolute zero. Okay, so I knew something was wrong there. I don't really know what I did. Like I said, I'm using my phone calculator. The real answer is 346. Okay. 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 I'm going to end this one here, and I'll come back and do a couple of these just to finish up. Okay.